Okay, hi everyone. I hope you have a very good day. And previously, we have learned in this chapter the idea of congruence. So, the idea of two shapes being identical. In this video, we are going to talk about similarity. So, two shapes being similar, right? And the tests that we can use to determine whether two shapes are similar or not. And I think we are going to look at the easier shapes, which is to look back at triangles, right? So we don't need to prove for other shapes, we just need to prove for triangles for now, right? So similarly with congruence, we're going to have similarity tests. So let's start off with the very first idea of similarity. So over here, I have two triangles, ABC and XYZ. So both of them have the same shape. So means that they are identical in terms of the orientation and so on, the angles. So if you take a look over here, angle A, angle X, they're the same. Angle B, angle Y are the same. Angle C, angle Z are the same. So let's say if I were to introduce you to a third triangle over here. So this third triangle is not similar to the first two triangles. What do we mean by the same shape is they have the same look, right? They will have the same look. It's just or they have the same angles between them. It's just that one of the shape is zoomed in of the other shape. So one is bigger, the other one is smaller, right? So over here, this blue triangle over here, even though technically speaking in English we call it same shape, is still a triangle. The other two are also triangle as well, but they don't have the same angles between them, right? So this makes the blue triangle not similar to the other two triangles. So the criteria for a shape for two figures to be similar is that they have the same shape but different size. So what we mean by same shape is that they have the same angle. So all the internal angles are the same. So for example, A equals to X, B equals to Y, and C equals to Z, right? The corresponding angles are the same, and the ratio of the corresponding sides are the same, right? So let me add one more word over here. It's not angles the same, is that the corresponding angles are the same. Yeah, I need to make it clearer. Right, so all corresponding angles the same and the corresponding sides have the same ratio. For example, AB over XY will give you one number, BC over YZ will give you another number, AC over XZ will give you another number, and these three numbers are equal. They are the same number. So they are going to be equals to a number K. So this means that one shape is proportional to another shape in terms of length. Okay, so it's a little bit different from congruence where all the sides, all the corresponding sides are equal. For this case, all the corresponding sides, they have the same ratio. Okay, a bit different. And without further ado, let me introduce you to three tests to show that the two shapes are similar. So we have the Aaa Similarity Test, we have the Sss Similarity Test, which is a bit different from the congruence Sss, and we have the Sas Similarity Test, which is also different from the congruence Sas, right? And for this Sas, right, it does not have to be in this order. It can also be an Ssa similarity. For congruence, we don't have an Ssa congruence due to the ambiguous case, but for similarity, we can do the Ssa, and it's a bit different from how do we prove the congruence, right? So we save that for later. We'll come to it later, but let's take a look at the Aa similarity first. So over here in practice now 13, in page 137, we need to prove that the two triangles are similar, right? So over here, we can match their angles. So we have a 60 degrees over here, right? And we have a 45 degrees over here. Wait, but I don't have 45 degree in the second one. So let us calculate the angle in the second triangle then. So angle yxz is going to be equals to 180 degrees minus 75 minus 60. The reason over here is this is angles on a straight line. Okay, so let me pull this to one side over here. So adjacent angles on a straight line. So lo and behold, if you were to press your calculator, you should be getting a 45 degrees. So this angle here is 45 degrees, and tada, we can match this one over here. Alright, so the thing is that for Aa similarity, we don't need to state all the three angles because of this property over here. The third angle is going to add up to 180 degrees. So if two angles are the same, the third angle will definitely be the same because they always add up to 180 degrees. Okay, so we don't have to do the hard labor of calculating the third angle using 180 minus the thing. We just need two angles because the third angle will automatically be the same. So let's try to match the two angles over here. We have angle A and Y, but let's write down the full thing. So angle BAC is going to be equals to angle ZYX. You have to match the vertices. So what do we mean by vertices? These are vertices. The corners are vertices. Alright, vertex Z, vertex Y, vertex X. So vertices X, Y, and Z. Right, and this one is equals to 60 degrees. Right, it is given. Right, the next one over here is angle BCA. It's going to be equals to angle ZXY. Right, and this is equals to 45 degrees, and this is what we calculated earlier, so we don't write the given. So we have two angles, which is sufficient to say that. Now for this one, we don't have a symbol for similarity, so usually we will need to write the whole thing out. So we have triangle ABC is similar to, okay, let's match the vertex. So A and Y, B will match with Z, C will match with X. So triangle YZX. And the reason for their similarity is AA. And we cannot just put AA. For similarity test, we need to end off with a similarity over here to differentiate with the congruence. So for congruence, we don't need to write SSS congruence, SAS congruence. We just leave it as SSS, SAS, and so on. But for similarity, we need to write down the word similarity over there to really say that it is similar. Alright, so this is the end of our first example, warm up. Now let's take a look at our second example. Right, the second example over here in B is two triangles, but they are attached to each other. So this is a shape that you have to remember because this is a very, very common shape for similarity. Okay, and especially RS and VU are parallel, so you need to be observant. So when you have two triangles like this and a pair of parallel sides, highly likely they're going to be similar already, or more or less you can confirm that they are similar. And how do we prove the similarity? Let's try to find out common angles or sides. There's no sides given, so let's focus on angles here. So the first pair of angles that we are definitely comfortable is these two angles over here. Do you see this? Right, these two angles over here. Why? Because these two angles are vertically opposite angles. So let's state these two angles over here. So angle RTS is equals to angle VTU, and this is because they are vertically opposite angles. Okay, so this is the very first one. The second angle that we can match is over here. Can I see this? No, okay. So this one over here. Do you see this? I have a set of alternate angles due to parallel lines. Okay, so over here, let me mark this angle and this angle over here. So I have my triangle TRS. Wait a minute, let me change color. So triangle TRS is equals to triangle TVU, and this is because of alternate angles, and the alternate angles come from parallel lines. So RS parallel to UV, right? So we have two angles, just nice. We can end off with a similarity. So triangle RST is similar to triangle VUT. So we need to match the vertices, and the reason of why they are similar is because of two angles. So Aa similarity. Okay, so this ends our second example. Okay, now for our third example, and this is another very common similar pairs of similar triangle, and this is actually like two triangles, one bigger than the other, and LM is parallel to NP. So the moment you see parallel sides and two triangles stacked on top of each other, most of the time it's going to be similar, right? So let's take a look at which angles that we can use to show similarity. So from the parallel lines, we have this set over here. Do you see this? We have 1 and 2. So this is what we call corresponding angles. We have this option over here. We have another corresponding angles over here. Okay, we have the second set. And the third angle that is actually very beneficial to us is this angle over here. This is the common angle to both triangles. Okay, so to make it easier, I'm going to use the common angle over here. So angle LKM. Okay, so angle, oh my god, okay, so angle LKM is equals to angle NKP, right? So this is because of common angles. They are the common one. So let me write them down. Now the second pair of corresponding angles are angle KLN and angle KLM and angle KNP. So this is due to corresponding angles, and the two parallel sides are LM parallel to NP. And because of this, let's match. So triangle KLM is similar to triangle KNP because of two angles. So the reason is Aa similarity. So over here in question 2, we see the stacked triangle, the one like before. So this is definitely going to be a similar triangle. So let's try and prove. Follow part 1. We show that these two triangles are similar. So we're going to do the same thing as before. Let us mark down our corresponding angles over here. Right? Otherwise, you can use this set of corresponding angles. No harm. Right? So either. And we have one common angle over here. Very nice. Okay, so with this, let us just write down two of the angles because the third angle is going to be the same anyway. So over here we have angle BAC is equals to angle DAE, and this is at side A, right? So I will call these common angles. This is a common angle, like the common side, right? So we have a common angle. Then the next one would be a corresponding angle, so maybe ABC. So triangle ABC is equals to triangle ADE, and this is because of corresponding angles. The two parallel sides are BC to DE. So because of that, triangle ABC is similar to triangle ADE, and the reason is because of Aa similarity, right? So must write the reason. So part 2, because they are similar triangles, we can write down the corresponding ratio of sides, or the ratio of corresponding sides. So find the length of DE. I'm going to look for DE, and I also need a BD, right? BD over here. Okay, so let's look at this now. So we have 8 and 12, right? So we need to do a little bit of matching, alright? So the first one, I'm looking for DE. Now, DE from the bigger triangle, I will match it with the BC from the smaller triangle. Okay, and then if this will be equals to AE from the bigger triangle, matching with the corresponding side of the smaller triangle, which is AC. So DE corresponds to BC, big over small. AE corresponds to AC, so big over small. So big, if it's big over small on the left, it will be big over small on the right. So DE is the one that I don't know. BC is 7 cm. AE is 12 cm. AC is 8 cm. So we just multiply the 7 to the other side, right? Just kick this to the other side, right? So DE is going to fetch us, it will be 21 over 2, so 10.5 cm, right? Then for length BD, let's take a look at AD first, right? So AD over AB, right, the long one is going to be equals to the AE, the long one, over the shorter one, AC, right? So corresponds like that. So AD over 6 is equals to 12 over 8. So AD would be 9 cm. So BD would be 9 minus 6, so it's going to be 3 cm, like this. Okay, so when we have similar triangles, we make use of the we make use of the corresponding sides, the ratio of corresponding sides. Okay, so what can you conclude about AB to BD and AC to CE for such a figure? So this ratio 6 to 3, which is 2 to 3, and this one 8 to 12, right, is also 2 to 3, right? So let's take a look at what can we write over here for part 3. Okay, so AB over BD. So AB is 6, BD is 3. So the ratio is 2 to 1. The next ratio over here is AC to CE, right? So AC to CE, it is 8 to 4, which is also 2 to 1. Okay, so the conclusion is that AB over BD will be equals to AC over CE. So these two ratios of corresponding sides are going to be equal. Okay, let's move on with the next kind of proof for similarity. Okay, in practice now 14, page 139, we are given 3 sides. So means that we're going to look for side. Now, this one I need you to pay a bit of attention. For this one, it will be different from the congruence side, because for congruence we just need to match and equal. For this one, we are going to look for 3 ratios of corresponding sides. So ratio. First ratio, second ratio, third ratio, and the ratio of sides. So that's why it's S, and S. Ratio of sides must be equal. So let's start to pair them and see which ones that we can convert. So maybe let's match 8 to 12 because they are the longer side. The shorter side is 5 and 7.5. The not so short side, the middle one would be 6 and 9. So let's do a little bit of calculation. So AC over XZ would be 6 over 9. Simplify this, 2 over 3. Right, so we get the first ratio. Second ratio would be AB over YZ. So AB is 5, YZ is 7.5. Use your calculator. You also get 2 over 3, right? The last one, we're going to need the last one, BC over XY. So BC is 8, XY is 12. Simplify, you get 12 over 3 as well. And because of these 3 sets of corresponding sides, right? Because of these 3 corresponding sides, the ratio are the same. So the conclusion is, okay, the conclusion is triangle ABC is similar to triangle XYZ. Wait, we need to match, sorry. ABC, so Z, Y, X, like that. Okay, we need to match the vertices. Okay, reason is because 3 sides. So S, we have to add in the word similarity. Unlike congruence, if you don't put in the congruence, if you don't put in any word, we'll assume that it's going to be congruence. So that's why we have to add in the word similarity here. And one more time, to prove Sss similarity, the 3 ratios of corresponding sides must be the same. Okay, so with this idea in mind, let's move on to practice now 15, where we only have 2 sides. So means we need to look for one angle to supplement this to form our Sss similarity. So let's take a look at okay, so we have 3 meters and maybe 5.4. Let me match this. And we have a 4 and a 7.2. So I think usually when we see this kind of question, usually it will be flipped. Alright, so let's take a look. So we have our JL over Ln. So JL over Ln would be 3 over 5.4. So 3 over 5.4 is gonna give me 5 over 9. Okay, the next one would be JK over LM. Wait, LK over LM. Okay, so this one would be 4 over 7.2. Just nice. Also 5 over 9. So we have 2 sets already. The last one is going to be the angle. Alright, so the angle JLK is equals to angle NLM. Okay, and this is because of vertically opposite angle. So we must write down the reason like that. Okay, so conclusion, the 2 triangles, triangle JKL is similar to triangle NML. Okay, and the reason is we have 2 pairs of corresponding sides and 1 angle, so we call this the SSA similarity. SSA similarity, like this. Okay, so this ends practice now 15. Okay, so we've come to this point in time where we're going to mix and match. We're going to use both congruence and similarity tests to solve geometry problems, alright, especially involving triangles. Okay, so in practice now 16, page 142, we have this diagram over here, show that ABC and ECG are congruent. So the first thing first is that if you are labeling, right, make sure you're using pencil to label. Use pencil to highlight, mark, and so on. Please do not use pen because you may need to redo the whole thing. So over here, or you may need to cancel and lose out on information, right? So the thing that we're going to see is triangle ABC. We're going to match it with ECG. Okay, so let's match and see. We have a 15 cm, we have a 15 cm. What other things do we have? We have this one over here. We have corresponding angles. Okay. Oh, and just nice, it is also given that we have a BC and a CG over here. So we have 2 angles, 2 sides and 1 angle. Let's check is that it's not SSA. So this is an SAS arrangement. Okay, sure. So over here, length BC is equals to length CG. This is given. For the angles, oh wait, we have a 15. We have a AC is equals to EG. This is equals to 15 cm. Also given. The last one is the angle ACB is equals to angle EGC, right? And this is equals to, or they are equal because of corresponding angles, the parallel one. And which ones are the parallel lines? BC parallel to EG, right? If you were to draw too thick, you cannot even see the parallel sign. Okay, so this is part 1. Part 2, show the ACD. Alright, so let's remove this. So the importance of, so this is really important to like use a pencil so that you can erase and redraw. Okay, so show that ACD. So we have ACD. Hey. Okay, ACD over here. Right, it is similar to EFD. So similar to this triangle over here. Okay, so the very first thing is because they are straight line, I'm going to have a vertically opposite angles. Okay, and the next thing that I need to take note is what else can I do? And okay, the third, so we have one vertically opposite angle. Most likely we can also make use of this 6 cm over here, right? So this 6 cm, right, and 15. So later we may be able to use this. Okay, so we need another angle. And actually just now, right, we have ABC and ECG. So technically speaking, right, this angle here is actually equals to this angle here. So let me write this down in part 2. So the first one is the obvious one. So angle ADC is equals to angle FDE, right? So this one would be vertically opposite angles. Alright. So the next one that I'm going to do is the orange color one, where angle BAC is equals to angle DEF. And this is because of congruence. Because triangle, like what we did above, triangle ACB is congruent to triangle EGC. Okay, so this one is how they restrict us. So now I have two sets of angles already. So my triangle ACD is similar to triangle EFD. Oh, no wonder something is missing. Because in part 1, right, I missed out the finale. The finale is triangle ABC is actually congruent to triangle ECG. Okay, and this one, the reason was because of SAS congruence. Okay, so I'm just going to leave it here. Now ACD is similar to EFD because of Aa similarity. Okay, so this is part 1 and part 2. Part 3, find the length of DF. So DF is actually mapped with this 5 cm over here, and we have a 12 and 15, just nice. Okay, so I'm gonna like DF, so part 3, so DF is the small one divided by the big one, which is DC. Okay, then the next one to try is AC and EF. So EF first, then AC. So DF over DC. DC is 5, EF is 6, AC is 15. So DE is going to be 18. Okay, so DE is equals to 18 units. Sorry, not DE, DF. Wait a minute, DF. Okay, let me correct this to DF. Okay, so DF is going to be, we multiply the 5 over to the other side. So you press your calculator, I should be getting a 2 cm. Okay, so this is how we do questions involving congruence and similarity. So right now we need to be aware that if we are showing congruence, the angles in part A can also be used in part B. and so on, and vice versa. Okay. Okay, the second example over here is we have a triangle and we have a parallelogram inside the triangle, right? Very common similar triangles. Okay, so we have a point X lies on the side AB of ABC, and AX to XB is in a ratio of 3 to 4. Let me put this here first. Ratio 3 is to 4. Then PQ, our points on CACB such that XP is parallel to BC and XQ is parallel to AC, right? So we give XP 15, XQ 16, find the length of BQ and AC. Okay, sure, but before we look at this, right, and in terms of ratio, we need to show that this triangle is similar first. So what I need to do is, let me show the obvious one. I'm looking for BQ. Okay, then maybe I can match with BC. Okay, let's take a look at how are we going to do this. First, APX. Okay, sure, let us split this to two triangles. Let's split this to this triangle and also that triangle. Okay, so this one over here, like this, like this, like this, like that. Okay, so let's let us do this then. Okay, so angle XAP is equals to angle BAC because this is a common angle. Okay, then the next one that I can ask for is actually this one over here, this one as compared to this one over here, right? So actually angle AXP is equals to angle ABC, right? So this is because of corresponding angles, and the two parallel lines are XP parallel to BC. Okay, so with this one over here, we can show that triangle AXP is similar to triangle ABC. So we cannot apply the result straight away. We cannot do the ratio straight away. We need to show the similarity first, especially for this chapter. We need to show the similarity first. So what we have here is BQ, right? So over here BQ. So BQ. Oh, actually this is 15 also. So it's actually not BQ. I'm looking at BC, right? So BC. I'm looking for BC, and BC over XP is equals to AB, big one, over AX. So BC, I'm going to write this as BQ plus 15, right? XP, I'm going to be equals to 15. AB to AX, so this will be AB is 7 units, AX is 3 units. So BD plus 15 is equals to, BD plus 15 is equals to 35. So BD, the length would be equals to 20. Okay. Okay, and after finding my 20, BD is 20. Sorry, not BD, BQ. Actually, have a BQ over here. Right? So this is BQ plus 15 is 35. BQ. So BQ is going to be 20. Yeah, so it's BQ, not BD. Okay, sure. Now the next thing that I'm going to do is I'm going to look for AC, but the thing is now that I need to reorientate a bit in terms of my my similar triangles, because in order to look for AC, which is up there, right, this AC over here, right, so I'm going to need to use this AC and this XQ, right? You see that AB and AC and XQ. It is very difficult for like 3 to 4 because I don't have this ratio over here for these three parts. Okay. The only thing that I have over here is that this portion over here is just 16 cm, right? Because it's actually from this parallelogram over here. Okay. So the thing about this is I need to reprove a set of to reprove that like XBQ and ABC are similar. So if you were to go on over here, so this is my proving steps. Okay, the first one is a common triangle at the bottom left corner, right? And another corresponding angle, one of the corresponding angles. So ABC is similar to triangle XBQ. And we have this first fraction. I can link this first fraction over here. Okay, and because of that, I will break down AC into AP plus 16, and over AP is equals to 7 over 3, like that. Okay, and 3AP plus 48, right? So I'm going to cross multiply. So this is what I get, and to rearrange, I get 4AP is equal to 48. So 1AP is going to be equals to 12, right? And because of that, AC will be 12 plus 16. It will give me my 28 cm, right? So this is actually a slightly longer way of doing this. Okay, so let me remove this. Let me shift this upwards a bit. Okay, so yeah, so this is a slightly longer way to look for my 28 cm. Okay, but the thing is that before you use the lesson that you need to learn is before you use the similarity, you need to prove that the two shapes are similar first, especially if the question give more marks. Okay. Okay, so let's take a look at practice now 17 in page 143. So previously what we did was to prove for similarity, and this one over here is that we need to check at whether they are similar or not. So they may not be similar. So the thing is that as we are matching, we have the 60 and 60, but we have a 70 and an 80 which doesn't match. So let's look for the third angle and see whether does it match or not. So the third angle is, okay, MON, you do the minus, so it's going to be 40 degrees because it's angle sum in a triangle. Okay, so we have PRQ equals to angle MNO is 60, but okay, the angle PQR is 70 and angle MON is 40. Alright, there's no 80 for the other angle, so therefore, right, the triangle PQR is not similar to triangle MON because it failed the Aa similarity test. We don't have the third angle is 40. Okay, so the 70 cannot match with the 40 and the 70 cannot match with the 80. Okay, so this is why it failed the Aa similarity test. Okay, and one more thing that we need to add also is the other one, triangle, no, angle OMN, right? Because like the 70 cannot match with these two, so we need to add this one more statement over here. So the 70 does not equal to 40 and 80. Okay, so because of that, it failed the Aa similarity test. Okay, so in this next question B, alright, so we have two triangles of three sides, so means that we are going to do the Sss test. Okay, so without further ado, let's do a little bit of matching for this. So the longest end and the the longest and the longest end, shortest end and shortest end, and then the middle one and the middle one. So I have my middle ones, I have my shortest lengths, and my longest sides. Okay, so you see how I match those, right? So the thing is, we're going to do the ratio one by one. Okay, so the first set of ratio QR and ST is 3 to 1. But PQ to SU, the blue color one, is not 3 to 1. It's 5 over 1.5, but it's not 3 to 1. And so because of that, the two triangles are not similar because it failed the Sss similarity test. So we just need to show that one of the ratio is out, then it will fail the Sss similarity test. Okay, for the very last one over here, we have a triangle ABC and triangle XYZ. So we have a 75 degrees over there, which means that I can actually map. But it doesn't make sense to map the 10 cm to 10 cm because one is big, one is small. So let me map something with common sense, which is 5 and 10, and then 10 and 15. Okay, so the thing that we can write is, for the first one, let's match the angles first. Oops, let's match the angles first. So we have a angle WXZ is equals to, angle YXZ is equals to angle ACB, and this is equals to 75 degrees. Okay, so the next thing is, we can also write this one over here. Okay, so XZ over AC, which is 10 cm over 15 cm, is 2 over 3. Okay, the next ratio that we can use is, but XY over BC is 5 over 10, and it's actually half. So the ratio is different now. So it means that this ratio is not the same. So because of that, triangle XYZ is not similar to triangle ABC because it failed the SSA Similarity Test. Okay, so this one is because it failed the SSA Similarity Test, right? So that's why it's not the same. So this one, the ratio that's not the same, that's causing the problem. So is it enough to only write one ratio? No, we need to write both the ratio to show that both of them are different. Okay, so the thing is, so this is all for similarity. Okay, so the idea of similarity is, one more time, is same shape, different size. So this means all the corresponding angles are the same and the corresponding sides have the same ratio. So once we show that two shapes are similar, we can make use of the ratios to solve for any unknown sides. So we have 3 tests before using the ratio: AA, SSS, and SSA similarity, which is different from the congruence. So that is all for today's video. Hope you had a good time following up with a very heavy topic, and hopefully you were able to understand this well and to apply this to your solving of the idea of solving similarity and congruence problems. All right, so that's all. Bye bye.